So I so yeah. So thank you, Ricardo. So I'm a senior researcher in on hereditary diseases of about vision, and I'm also scientific mediation project manager in Genopolis. You have here my email if you want to ask something. So I will begin. I will talk about also about speaking on to different publics. And for the to begin, I will define a little bit the different public you can see. Not and I will after that talk more about teenagers, because for the virtual congress it will be more for teenagers. So first, I don't know if you know about captive and not captive audiences. If you are on a night, researchers' night, people are here, but they want to be here. So we call that non-captive. They want to be here, so they are motivated at the beginning. For children, it's not always the case, because the families, the parents want to come, and the teenagers not are obliged sometimes, but they are, we call that semi-captive. So one thing to know about general public and families is that the average level of knowledge for adults is about 15 years old teenager. It's not, we usually think that it's we know more than teenagers, but it's not the case. And if you think about, I'm a biologist, if you talk to me about chemistry, I will not know a lot about chemistry, because it's not my knowledge now, and so I lost what I knew in high school. So think about that. You don't have to be very, very precise in terms with adults, because they don't know so much. You have to be as non-specialist as with teenagers, even children sometimes. Children are always captive is in classes, but they are always ready to try. It's easy with them because they want to know, they want to discover. You have them, their attention and their motivation really easily until 12, around 12. For teenagers, it's not the same, because they are often captive when you go to high schools, and they are really often reticent at first. They want to seems to be blasé, oh, I'm not interested, no. And when you ask question, they usually don't want to answer at the beginning, because if the first who answers is trying to please the professors, the people who's talking. So it's not so easy. For retired persons, they are not captive, and they are doing usually a lot of conferences. So they love to discuss, and they know a lot of things, but completely about everything. So it's really funny to talk with them. And the public, which is particular, is the patient public. I told you I work on vision, and so we discuss regularly with the patient with problems, degeneration of the retina, and they are non-captive, and they are experts of their disease. If you talk to them about other things in biology, they are not so they don't have so much knowledge, but on their disease, they are really, really specialists. So you have to be specialist on that, or tell them, I don't know. So that was for the different publics and the particularity of each. For teenagers, the public, it's a difficult public, as I told you. I don't know, do you see something gray on my presentation or not? Oh, it's okay. No? Okay. So it's a difficult public, as I told you, and we did a lot of questionnaires and discussed with them, and discovered that teenagers, as general public, but particularly teenagers, consider that the scientist is like that. It's an old man, usually and it's impossible to understand what he says, and he doesn't want to share. So it's really funny, because when we discuss with them, at the end, we usually have the response when we ask them, do you think differently about the scientists than before we discuss with you? And they said, yes, it's funny. They are nice. They are nice people. They are passionate people. So it's not evident for the general public, and particularly for teenagers, then that scientists are interesting people and passionate people and fun and nice people. So we have to change this idea, and it's not about only science, but also about science careers. There are a lot of careers in science. It's not always researchers. There are a lot of other careers, and it's important too. And the idea that they work in team is important too, because it's not evident for them. So ideally, you have to involve them at the beginning. Ask them, what do you think about that? It's what Mirtani said about hook. You have to keep them in there. Do them ask their opinion about that and that, and wait. Sometimes the first answer will wait a little, but you have to do that. Use humor. That's evident. Use everyday examples. It's important for me. For example, I explained that in retina, you have two types of photoreceptors, receptors who interact with light, and the sort that the photoreceptors are interacting with low light is not in the center of the retina. It's slightly outside the center of the retina. And I tell them that, and then I tell them, if you want to see at a star at night, you have not to see, you should see not directly on the star, but slightly outside the star. And then you will see it better. And then people will say, oh, did I do that? Oh, I have to try. And then they are interested and they are motivated. Okay, so everyday examples. Do not hesitate to share personal anecdotes. The idea is, again, that we are normal people. We are normal people. We can discuss normally. Do not hesitate to share also your hesitation during your careers. I have an Italian colleague who told them, people, that during her career, she arrived in Montpellier because she was following a boyfriend. And she said, okay, I'm not with a boyfriend, but I'm still in Montpellier. Okay, but with that, it's simple, but it shows that choices are not always scientific, and we have life pathway that are like normal people. Think about your vocabulary. Sort the essential word, and we will do that in the practical exercise, from non-essential. In our way of talking, we have a lot of difficult terms for the general public. And we always think, and I'm the same at the beginning, we always think that every difficult words are important, but it's not. And you have essential words. If you work on RNA, you have to explain RNA. You cannot always work without telling the children that you are working on RNA. But if you are working on RNA and with this technique and this technique and this techniques are not interesting, except if you use specifically this technique, and then you have to explain it. But think about what you need so that they understand and what they don't need. And also beware of double meaning words. We have a lot of double meaning words. For example, I have a colleague who said, I use a green fluorescent marker to recognize my mutated mice. So he was thinking about that, and the kids were thinking about that. Fluorescent marker, no, I don't understand. And the other example, it works better in French, but it's the idea. she said, I am studying microphone, and we were all thinking about microphone. And here it's only working at not when you write it, but when you hear it. We didn't understand what she was saying, because she was just saying microphone, and for her it was evident. Okay, so think about your terms, think about the word you use, to think if it's not the same word of something they are completely which is completely normal in the normal life, but it's not the same in what we use in scientific words. Use comparison. Yes, I completely agree with Mirtani. And for example, I work on mitochondria. I use also the explanation with DNA. The mitochondria, we could say, it's the cell's powerhouse, and it produces energy that can be stored. If you explain that, it's easier for the kids and for the teenagers to understand the following explanation. Another thing also, never say anything false. There is a big crisis of trusting scientific personnel in lot of countries, and it's really, really important that you never said anything false. You can simplify, but never to the point that it begins to be false. And if it's you do a comparison, but it's not exactly that, say it's not exactly that. It's a little like that, but not completely that. Because if you don't say that, and the teenager discover after that you didn't tell the truth, it will alimент the confusion and the thing that scientific can't be trusted. So it's really important, never say anything false. So now we will do a little exercise.
Yes. Marie, sorry, you have 1 or 2 minutes and you have to do the explanation of the exercise.
I have still 2 minutes? Okay,
yes.
So do you have questions?
You can finish, but the next step is to do the explanation.
No. The next step was that, to explain because it's 11. So I was explaining Darby. It's okay?
Okay, yep. Perfect.
Okay. So
just one question. I will do the rooms, maybe 3 people, just in case someone left, no one is alone in the room. So not 2 by 2, but maybe 3, 2 by 3.
Yeah, good thing. So now you will practice that, thinking about what your vocabulary, thinking about what you can explain, and then we will talk about that. So, sorry, I think there is a question. Oh, okay, sorry. Okay, no problem. So we are now in a common virtual room. You will be reparted. We will going in virtual rooms with 2 or another people or 2 people. So, and you have 10 minutes to explain your subject to the other or the others, and the others have to note difficult terms and give it to you. Okay, so the idea is that you think about the terms, but if it's difficult, your listener will note it and give it to you. And after that, we will come back in the common virtual room. We will and go in other virtual room to discuss these terms. So I think the best thing is to note the difficult terms in your chat, and then you can copy and paste, because you two will not we are not sure that you will be in the same room after. Am I clear? Okay, we have 1 yes, so I think it's clear. Okay, thank you. So you will be going to this virtual room. Be careful, you have 10 minutes. So you have 3 to 5 minutes to explain each.